Okay guys, so here's a question about linear algebra. We'll be solving something with parallel lines, perpendicular lines, gradients, intercepts, all that stuff. So the equation of a line L1 is the following: y minus 3x plus 5 equals to 0. For this line, find the x-intercept and the gradient. So here's my recommendation. When you solve such questions, you want to write it in the form of y equals to mx plus c. Then you want to do the following: y equals to transfer the minus 3x and the plus 5 to the other side. So minus 3x becomes 3x and plus 5 becomes minus 5. So now you have y equals to 3x minus 5. For the first question, finding the x-intercept, you can calculate that by making y equals to 0, because that's what the x-intercept is. It's the value of x when y equals to 0. So you do 0 equals to 3x minus 5, and then you can say 0 plus 5 is 5 equals to 3x, and then x is 5 over 3. So that's your x value for this intercept. The answer, however, to the question, you have to say x-intercept bracket, and you put the coordinates 5 over 3 comma 0. So that's one thing. Then let's find the gradient. Well, this helps because as I wrote this equation, I can find the gradient directly. The gradient is the number next to x, so I can just say the gradient m equals to 3, and that's gonna be it. Then for question B and C and D, I'll just go here below because I need the space. So we have the following: a second line L2 intersects the y-axis at the point of P with coordinates 0, 2 and is parallel to L1. For question B, they ask, find the equation of L2, give your answer in the following form. Okay, well, what do we know about parallel lines? When we have parallel lines, the gradients of those lines are equal. So the gradient of the second line, M2, equals to the gradient of the first line, M1. Now, what's that? Well, we concluded from part A that this was 3. So I'm going to put the 3 over here. So the equation of this line is going to be y equals to 3x plus c. That's where we are at the moment. Now, how can we finish the question? We can finish the question by using the point P with a substitution. So we know that the point of 0, 2 satisfies this equation. Well, if I'm going to substitute 0 for x and 2 for y, let's see what we get. I will have 2 equals to 3 times 0 plus c, 2 equals to 0 plus c, 2 equals to c. So I found c. And now I can finish the question by saying y equals to 3x plus 2, and that's the form that the question wanted me to write. So we are good. This was part B. We did it. Let's go to part C. A third line, L3, passes through the point Q with the coordinates 3, 1 and is perpendicular to L1. Question C says, find the gradient of the line L3. Okay, so we are going to write the following: that the line L3 is perpendicular to the line L1. That's the sign or the symbol for perpendicularity. There is a property when it comes to perpendicular lines that the product of their gradients, m3 times m1, must equal to minus 1. Then we know that m1 is 3, so we're going to write 3 over there. This is m3 times 3 equals to minus 1. And then m3 equals to minus 1 over 3. And we are done. That's the answer to this question. Let's carry on. Question D, the last part. They say, find the equation of L3 in this form: ax plus by plus d equals to 0, where a, b, and d are integers. Alright, don't forget that next to the gradient that we found, we can also use this point as substitution into this line we're looking for, the point of Q with the coordinates 3, 1. Let's do that. Q coordinates 3, 1. We'll be using this. So we know that the gradient equals to minus 1 over 3. How can we solve this question a bit faster? I like to use the following form: y minus y0 equals to m, which is the gradient, times x minus x0. And I'll explain you what I mean. What I want to explain you is the y0 and the x0. These are coordinates of a point on the line. So if we know that Q is a point on this line, on the line of y, okay? Because the equation of the line is gonna be an equation of y equals to something, right? These coordinates have to be part of this equation. So this is our x0, 3, and 1 is the y0. Now go back and substitute y minus 1 equals to the gradient of minus 1 over 3 bracket x minus x0, which is 3. Then keep doing the math. Open the brackets. You have y minus 1 equals to minus 1 over 3 times x. And then minus 1 over 3 times minus 3 becomes positive 1, because 1 over 3 times 3 is equal to 1. These are cancelling out. Are we good? Not yet. I want to write this equation as follows. Look what the question said. It was up here somewhere. This is what I want, ax plus by plus d. So I need to write my x coefficient, my y coefficient, a constant, and all that equals to 0. So let me do that. Since I have here the beginning of my equation, minus 1 over 3 times x plus 1, I'll take this one over there. So y becomes minus y, minus 1 becomes plus 1. When you transfer terms, you change their signs, remember? And then you put equals to 0. Then keep going. You have minus 1 over 3x plus 1, that's plus 2. And then you have minus y equals to 0. Are we good? Not yet, because the numbers next to x, such as a and then minus 1 here for b, and this is our d, all of these have to be integers. We don't have integers, we have minus 1 over 3 as a rational number. So because of that, we have a bit of a problem to fix, but easy to fix, okay? Because we're going to multiply this equation by 3, and when we multiply this equation by 3, the minus 1 over 3 times 3 becomes minus 1. So now I'm just going to have minus 1x, or just minus x, and then minus 1 gets multiplied by 3, that's minus 3y, and then plus 2 gets multiplied by 3, that's plus 6, and 0 gets multiplied by 3, that's 0. Now we reached the final point. Hope this all makes sense. If you like the video, please leave it a like. If you follow this course of IB, AI, standard level, make sure you subscribe, because I'll be having a lot of content to make all this course much easier. Thank you very much for watching. We are done.